Good morning. This lesson is for my Trig-Precalc class, but before I get started, I want to say I hope that everyone's doing all right out there. Now, I do know the name of this lesson. It's Chapter 6, Practice Quiz Review. We're going over the practice quiz. And that's our one goal. So let's go ahead and jump into that goal. And we're going to go through problems 1, 2, and 3 first. And the directions for problems 1, 2, and 3 was to determine the number of possible triangles given this angle measure and the two side lengths. And we actually do have 3 steps in order to determine how many possible triangles we will have. First, we need to rename an angle and its opposite side, angle A, and length A, and rename the remaining side, length C. The second thing we need to do is find the height of our triangle, and the height is going to be the length of C times the sine of our angle A. And third and finally, we're going to use the angle side-side flow chart to determine the number of triangles we have. Notice there's nothing about angle A being a right angle. If it was a right angle, we would have a right triangle, and we wouldn't need this. All right, so let's go ahead and jump into this. The first problem, I don't need to rename because I have angle A and its opposite length already named, and the remaining is C. So step 1 is done. I'll write a little checklist to keep track of where I'm at. Now I need to find the height. Get my calculator machine, make sure it's on degree. So height is the length C times the sine of 145. And that's 15.48. So the height is roughly 15.5. All right. And now we're going to use our angle side-side flow chart. All right. Well, I've got an obtuse angle, so I'm here. Let's see here. A is larger than C, so that means that this has one triangle, right? Obtuse, A is larger than C, one triangle. All right, problem 2. We'll go through the 3 steps. Angle A and its opposite length are already named, and the remaining side is C. So again, I don't have to do the first step. Step 2, let's find the height of this guy. Again, height is going to be C times the sine of 65. So it's 24 times the sine of 65, and that gets me to 21.75. So in this one, the height is roughly 21.8. And let's go through our flow chart now because we've done the second step. Angle A is acute. All right, is A less than the height? Yes. 12 is smaller than the height. So this means that we cannot have a triangle. So problem 2 is no triangle. Problem 3. Again, we have to go through our 3 steps. This time I am going to have to rename it. This is no longer angle C. This is now the measure of angle A. And its opposite length is now no longer C, it's now A. And this length is no longer B, it is now C. All right, so I renamed it. And again, the reason why we're renaming it is instead of having to learn different formulas or different versions of the same formula, if we just rename it, we can just use the same formula we have. And it helps eliminate mistakes as well. I guess you can still make a mistake in renaming it, but hopefully we don't. All right, so now let's calculate the height here. We need to find the height. The height is roughly going to be equal to, let's see, my value of C now is 33, so it's 33 times the sine of 37. And that's 19.85, so we'll run that to 19.9. Okay, so angle A is acute. A is larger than the height, so I'm not here. A is not equal to the height. A is not greater than C, but the height is shorter than A, and A is shorter than C. So in this case, we're actually going to have 2 triangles. This is a 2 triangle case. All right, so I finished the first 3 problems. I'm going to come back and do the next 2 problems. So let me clean this up and I'll be back. I'm back, so let's go ahead and finish this practice quiz. We have problem 4 and problem 5, and the directions are to solve each triangle. I wrote down a couple steps. Draw a triangle, add the measurements, and then set up the law signs and solve equations with one unknown. The reason why I'd like you to draw the triangle is so you know what you have, and you know what you're missing. So I'm just going to draw is the triangle going to match the measurements? No. But at least I know what measurements I'm missing and what measurements I've found. So let's go ahead and work on our first goal for this, or the first step. And I'll just go your A, your length A, your length B, your angle B, your length B, your angle C, your length C, and I'll just fill in what I know. I know that this measure is 36 degrees. I know that this measure is 15 degrees. I know that this length is 45 units. I don't know what the unit of measurement is, but I know it's 45. Now, because I see that I have 2 angles, I can find the third angle using the fact that the 3 angles add up to 180 degrees. So 15 and 36 gets me to 51, and then I take away 51 from 180, and I think that gets me to 129. So the measure of angle B, and I'll write it in another color so it's something I know that I found. The measure of angle B is 129. I really hope that's correct. All right. So now I can set up the law of sines here. So it's going to be sine of angle A, which is 15 degrees, divided by its length, opposite length. That's equal to the sine of B, which is 129 degrees. And that's going to be divided by its opposite length, which in this case is 45. And that's equal to the sine of C, which is 36 degrees. And that's divided by its opposite length. All right, and so I have 2 equations with one unknown. I can solve for A with this equation, and I can solve for C with that equation. So let's solve for A real quick. So, sine of 15 degrees divided by A equals sine of 129 degrees divided by 45. Let's get rid of the denominators. So I'll multiply everybody by the denominators. So this will be A times 45, and this will be A times 45. On the left, the A's cancel, and on the right, the 45's cancel. And so now we're left with 45 times sine of 15 and that's equal to sine of 129 times A. Now I just get divide away the sine of 129, and I've isolated the length A. So A is now equal to, I'm going to run out of room. A is equal to 45 times the sine of 15 divided by the sine of 129. All right, so let me get my calculator machine and let's figure this out. Let's see here. So it's turn it on. There you go. So it's 45 times sine of 15. Close that parenthesis, divide you by sine of 129, hit enter, and the length of A is roughly, well, it's 14.98, so that's going to round up to 15. So A is 15, roughly. A is roughly 15, and now let's find the value of C. Now, notice that A and C are in the same location of the problem, and so you can figure that the steps used to solve for A would be the same steps used to solve for C. So if we covered that up, we would multiply, so the C would move over here, the 45 would move over here, and then we would divide away the sine of 129. So the length of side C is going to be 45 times the sine of 36 divided by the sine of 129. Let's use our calculator machine for this value. Sine of 45, wait, let me do this right. 45 times the sine of 36, close that parentheses, divided by the sine of 129, and that is equal to 34.03, which rounds to 34. All right. Okay, I was writing it backwards. All right, so let's go ahead and move on to problem number 5. And again, before I move on, I've solved this one because I found all the measurements. All right, so let's see here. So I have one angle measure on this one and 2 side lengths here. Okay, so let's just draw our triangle so we know where we're at. And again, this triangle is not going to match the measurements because this is obtuse. Oh, email. This is obtuse. All right, so angle A, side length A, angle B, side length B, angle C, side length C. And let's write our measurements that we know. The length of C, or the measure of angle C is 117 degrees. The length of B is 32. And the length of C is 34. Okay, so I need to find an angle A, an angle B, and a length A. All right, so let's write our law of sines. So we get the sine of A divided by the length of A, and that's equal to the sine of B divided by the length of B, and that's equal to the sine of C, which is 117, divided by its length, which is 34. All right, can't solve that equation because I have 2 unknowns, angle A, length A. I can solve this equation. The only unknown is angle B. So let's go ahead and figure that out. So sine of B is divided by 32 is sine of 117 divided by 34. Now in the previous problem, what I did was I went ahead and multiplied everyone by the denominator terms to get rid of the fractions, but I don't need to do that in this one. I only need to get the 32 to the other side, so that's all I have to multiply everybody by, right? So don't just blindly solve. Take a second and look and see what you got, and then that way you can minimize the amount of work that you have to do. Right? So the sine of B is equal to the sine of 117 times 32 divided by 34. Okay, so remember we need to use the inverse function when we are calculating an angle, right? So it's going to say arc sine or sine inverse. So let's see here. Second sine of 117, close the parentheses, times 32, divide that by 34, close all those parentheses, hit enter, and it's 56.99, which rounds up to 57 degrees. Okay, so 57 degrees. I'm looking at this because I'm wondering if I made a mistake. Let's continue. So 57 and 117 means that together, these guys, I didn't draw the triangle right, so that might be what's throwing me off a little bit here too. So 57 and 117 takes me to, what is that? I got to do some math in my head. If that was 120, it'd be a 177. Is that right? Yeah, 177, so I'm at 174, so I think the measure of angle A is 6 degrees, right? 6 degrees? Is that that right? 36, so 63. Yeah, that'll make it there. All right, so 63. All right, 63 and 117 is 180. I was trying to think and nothing was happening. All right, so now we have a measure for angle A. So now we can work on this problem. So we can now say the sine of 6 degrees divided by the length A is equal to, and I'm going to set it equal to this, sine of 117 divided by 34. And again, look, I have an unknown in the denominator. I've already dealt with this before. So I multiply everyone by A and 34, right? And then, well, I'll show you the steps. So A and 34, A and 34. Here the A's cancel, here the 34's cancel. I'm now left with 34, come on, you can do this. 34 times the sine of 6. I wanted to turn that into a B. I gotta make my 6's look more like 6's. There we go. And that equals the sine of 117 times A. Divide out the sine of 117. And that means that A is equal to 34 times the sine of 6 degrees. Make that a 6. The sine of 6 divided by the sine of 117 degrees. I can do this. I'm really trying to think and nothing's happening. Hamster wheel spinning, but nothing's happening. I'm just checking to see how much time I got. All right. So to find the length A, and it better be the shortest side because it's opposite the smallest angle. Okay, so we have 34 times the sine of 6. Divide that by the sine of 117. And that is going to be 3.98, which rounds to 4. So the length of A is 4. I'm going to keep with this, so it's roughly 4. All right. So hopefully I've answered any questions that you've had on how to do these problems. I've clarified some things. I do want to see you draw the triangles so you know what you have and what you're missing, and fill it in as you work through. And I'll be looking at this to see if you have the right numbers in the right place. So I'm going to go ahead and end it here. Again, I hope everyone is doing all right out there. Have a great day, everybody. Bye-bye.